This video addresses a very specific kind of trig problem where they effectively give you one trig ratio. Like they'll tell you that the sine of the angle is, 1/4, and they'll ask you to find other ratios. Like they might ask you to find cosine, they might ask you to find tangent. There are a couple of ways to do these problems. The way I'm going to do uses the unit circle. Another one really heavily uses all the trig identities that we know. I'm just a fan of the unit circle. You guys know that by this point. So the steps in this process. First, you're going to want to determine the quadrant of the angle that you're working with. Usually that's going to be given to you, and what I mean by that is that they'll often tell you that the angle that you're working with is, for instance, between pi over 2 and pi. And if they do that, it means great, you know that the angle you're looking at is a second quadrant angle. If they don't tell you exactly that, you can generally infer from the sine of the ratio that's been given to you, and I'll get to that in just in the next example. The next thing you want to do is you're going to want to draw a unit circle triangle for that quadrant. So for instance, if you sort of picture your unit circle here, if you know that your angle is in the second quadrant, the triangle that we draw is always like this. If you're in the first quadrant, you're looking at this. If you're in the third quadrant, it looks like this, and the fourth quadrant looks like this. In the past, I've heard this diagram referred to as like the Bowtie Diagram. That basically just indicates to you that this is always how you should draw your shapes, and the angle that you're looking at is always this angle that's inside here, right? So, for instance, if they had given us this one here, if they said, oh, your angle is going to be between pi over 2 and pi, that would tell me that I would draw that triangle, because that's what the second quadrant triangle is supposed to look like. I would put my angle x right there, and then, I can label the appropriate side. So if they gave me sine, I could write down what the opposite and hypotenuse sides are. If they gave me tangent, I could write down what the opposite and adjacent sides are. The idea is you can start to fill in that triangle. And the third part is you complete the triangle using the Pythagorean theorem, which means you could find the other side of this thing, and then find the other ratios that you need. At this one, I'm going to get into our examples so that you can start to see how this works. They're really neat problems. Hope you guys enjoy them. So for this one, given that the secant of x is negative 13 over 5, and x is between 0 and pi, find the exact values of sine and cosine. And then hence we're going to want to find sine 2x and cosine of x over 2. We'll get to those in a minute. So the first step in dealing with this problem, notice that, they gave us one trig ratio, right? So I need to figure out what quadrant x is in. And according to this, it's either in quadrant 1 or 2. So I know I'm either going to be using this triangle style or I'm going to be using this triangle style. Right? So which one is it going to be? Well, secant of x being negative 13 over 5, what does that mean? Secant of x. What's another way of writing that? Maybe I should ask. Well, that means that the cosine of x is negative 5 over 13. And now you sort of have to think, where can cosine be negative? Cosine can be negative either in the second quadrant or in the third quadrant. Right? But we knew up here that it had to be first or second quadrant, so basically I know that I'm going to have to use a second quadrant triangle diagram to work through this problem. Right? So my setup here is, here's my second quadrant triangle. I'm not even going to try and draw it to scale. This is my angle x. Now, with secant of x is 1 over cosine, which basically means that it is the hypotenuse over the adjacent, right? Which means I know that my hypotenuse is 15 and my adjacent side is 5. So this is 13, this is 5. Now, one catch here. Notice that this is actually negative 13 over 5. So the question is, where is that negative supposed to go? Right? Well, the negative is really never allowed to be on the hypotenuse, because the hypotenuse doesn't have like a direction. In fact, it actually makes perfect sense to put the negative here with the 5, because this side is going backwards. Remember, as we've always read these things, if you're in the second quadrant, this x-coordinate is always negative, and in fact the y-coordinate is always positive. Right, so I'm going to put the negative there. So that was step 1 in this process. Right? Step 2 is then to complete this triangle, right? So if I use the Pythagorean theorem, I'll end up with 5 squared plus question mark squared equals 13 squared. If you work that out, you'll find out this side over here is going to end up being 12, right? And, it could be plus or minus 12 when we do the square root in there, but again, because I'm in the second quadrant, I know that this side is going up, and so because of that, I'm going to leave this as positive 12. Now that I have this, now that I've completed this triangle, it's not difficult for me to go back and say, okay, what then is the sine of x? Well, the sine of x would be the opposite side over the hypotenuse, so the sine is 12/13. What's the cosine of x? Well, cosine of x is adjacent to, we actually kind of knew that one from earlier, it's negative 5/13. So these are the initial values that they ask for. They ask us to find sine and cosine. And finding sine and cosine is like the best thing you can do, because once you have sine and cosine, it's pretty easy to find everything else. So for instance, now that I have those values, us going back and finding out what the sine of 2x is, and what the cosine of x over 2 is, should be fairly simple, right? With these things, I'm just going to use those identities, the things we talked about in the previous several videos in the sequence, right? So what is the identity for the sine of 2x? How do I find out what the sine of 2x is? Well, it's supposed to be 2 sine of x times cosine of x. Now, I mean, if only I knew what sine and cosine were. If only I had, managed to figure out at some point what sine and cosine were. Hey, they're over there in red. If I just plug these things in, 12/13 and negative 5/13, I'm going to end up with, let's see here, that's negative 120 over 169. And there it is. That's apparently the sine of double what that angle is. And I might ask, does it make sense that we would have a negative sine value? I would say yes. If you think about the fact that this angle was a second quadrant angle, doubling that is going to put me all the way down here in either the third or the fourth quadrants. And when that happens, I'm going to end up with a negative sine value. Okay? So now next up, we've got the cosine of x over 2. So the cosine of x over 2, our identity for that was the square root of 1 plus cosine x all over 2. And you may recall that this had a plus or minus on it, so we'll deal with that in a little bit. So I'm going to end up here with plus or minus the square root of 1 plus negative 5/13 all over 2. If I simplify this, I'll end up with plus or minus the square root of, let's see here, that's going to be 8/13 all over 2, which means it's going to end up being the square root of 4/13. And I'll be honest, I'm not really worried about the square root on the bottom there. I'm okay with that answer. My bigger question is, should this be positive or negative? And I want you guys to think about that. I want you to think about the idea that the original x angle was a second quadrant angle. It was somewhere between 90 degrees and 180. It was somewhere in this range. So it was, somewhere in here. When I cut that angle in half, should I expect the cosine to be positive or negative? And hopefully you're pausing the video and doing that. If your angle is over here in this quadrant, that means the biggest it is way over here at like 180, almost 180 degrees. When you cut almost 180 degrees in half, you end up here. If I cut anything smaller in half, I end up with, a smaller half of that thing. I mean, even if I were to cut, 90 degrees in half, I'd still end up with like 45 degrees. All of these angles over here that I'm going to be getting are in the first quadrant, and in the first quadrant, those values, the cosine values, are positive. So that means the answer to this question, the answer to the cosine of the half angle, is the square root of 4/13 as a positive value. And so what we just did is we just took one ratio, we just took a ratio of secant, and we managed to come up with like 4 other ratios that we could do. I know it took a long time in this one. Hopefully the next one will be a little bit shorter. So this is the same kind of setup. They want us to find the sine of x over 2 and the cosine of x over 2 if the cotangent of x is negative 4/3 and the angle that we're looking at is between pi over 2 and pi. So let's sort of, I'd like you guys to pause the video and go through this on your own. If you need a little bit of guidance, you can sort of listen to me go through step by step, but I'd really like you to try as much of it as you can on your own. So our first step is supposed to be where we identify what quadrant the angle is in, right? So in this case, that's pretty easy. They tell us right here. So step 2, we're supposed to draw the triangle that goes with that. So pause the video, make sure you know how to draw and hopefully also label that triangle. So the triangle I'm working with is a second quadrant triangle, which means it's going to look like this. The angle I'm working with is x, which I'll put right here. And to label it, we know that the cotangent of x, which is supposed to be adjacent over opposite, that's supposed to be equal to negative 4/3. So that means that the adjacent side is 4 and the opposite side is 3. Now in the previous problem it was obvious where the negative was going to go because it wasn't allowed to go in the hypotenuse. In this case the negative could go with the 4 or it could go with the 3. Based on the triangle, which one does it have to be? Right? We know that the negative has to go with the 4 because in the second quadrant that direction is negative. In fact, this direction is positive. Okay? So now that I have that done, I can complete the triangle. Completing the triangle should be pretty simple because this is a 3, 4, 5 triangle, Pythagorean triple. So we have 3, 4, 5 there. Now that I have those things, I can begin to answer the questions of what the sine and cosine of x over 2 are. So what we might want to do is we might want to actually write down what the identities are for those. To compute the sine of x over 2, I'm supposed to do the square root of 1 minus the cosine of x all over 2, and there's a plus or minus on that. To find out what the cosine of x over 2 is, I'm supposed to do plus or minus the square root of 1 plus cosine x over 2. So for both of these, it's pretty clear that I'm going to need to know what the cosine of x is. So I'll come back up to this triangle. What is the cosine of that angle? Well, adjacent over hypotenuse is going to be negative 4/5. So taking that value, I can plug it into these things down here. So this will be plus or minus the square root of 9/5, 1 minus negative 4/5 all over 2. Let's see here, that ends up being plus or minus the square root of 9/10. And we might as well finish this one out while we're here. So is this going to be positive or negative? Well, the same thing we saw in the previous one. When you take half of this angle, it's going to end up in the first quadrant. The sine in the first quadrant is positive, and so we're going to end up with our answer being positive square root of 9 over 10, which you could make 3 over root 10 if you wanted to. You could even simplify down to 3 root 10 over 10 if you really, really wanted to. Any of these things is acceptable to me. The only reason you need to know the differences is that when we do multiple choice, you need to pick the right one. For this one over here, we'll have plus or minus the square root of, and this one's going to be a little bit different. This is 1 minus 4/5 over 2. So that'll be 1/5 over 2, which is 1/10. And by the same token, this is going to end up being the positive value, so my answer here ends up being positive square root of 1/10. So we'll have plenty more examples of these in class. Hopefully they made sense here, and I'll see you soon.